So hi everyone and welcome to this video on applying the basic rules of integration. And for this video, we're gonna focus explicitly on our discussion on definite integration. So definite integration. So in the last video, we did some examples on indefinite integrals. Now we're gonna have definite integrals, in which it's roughly the same process, except that we have to substitute values that are in our defined range. So those values exist here. So you have a lower limit, which is that number there, and you have an upper limit. So that's expressed in our integral. So let's start. So we'll do 8 examples for this video. So we have integral of 3x squared minus 4x. So first step, let's factor it out first. So that's 3 integral 1 to 2 of x squared dx minus 4 integral 1 to 2 x dx, right? And if we do the integral, right, this is the same as saying 3 times x cubed all over 3 evaluated from 1 to 2 minus 4 times the integral of x squared all over 2, okay, evaluated from 1 to 2. So we don't have a constant anymore because this is definite integration, so we have a definitive answer for that. And we're going to find that this should be equal to 3 times the first, if we substitute 2, that's going to be 2 cubed all over 3 minus 1 cubed all over 3 minus 4 times 2 squared all over 2 minus 1 squared all over 2. This is equal to 3 times 2 cubed over 3, so that's 8 over 3, minus 1 cubed, that's 1 over 3, minus 4 times 4 over 2 minus 1 over 2. And we get 3 times 7 over 3 minus 4 times, in this case, that's 3 over 2, right? So we can cancel this out. So that's going to be, and then we can simplify this as 2. So that's just going to be 7 minus 6, which is equal to 1. Therefore, the solution to this is equal to 1. Okay. Next, we have integral from negative 2 to 2 of x cubed. So integral of that, that's just x raised to 4 all over 4, evaluated from negative 2 to 2. So we have 2 raised to 4 all over 4 minus negative 2 raised to 4 all over 4. So this one will be equal to 16 over 4 minus 16 over 4, because if we do it 4 times, so that will still be a positive number, and then that's going to be 16 over 4, which will be equal to 0. Okay. So next one, you have here integral of e raised to x. So that's just e raised to x evaluated from negative 1 to 1. So we have e raised to 1 minus e raised to negative 1. And that's just going to be equal to, approximately equal to 2.35040. So if you solve for that. Next one, we have here a two-term problem. So we have, we can simplify this if we just spread it. So that's, break it down into 2. That's 0, 1, x dx minus, if you recall, square root of x, so this term here, that's just equal to x raised to 1/2. Okay, so we can express it as 0 raised to 1, 0 to 1, x raised to 1/2 dx. Then we can simplify it, so integral of x, that's just x squared all over 2 from 0 to 1 minus, that's gonna be, so that's going to be x raised to 3 over 2 all over 3 over 2, or 2x 3 over 2 all over 3, right? From 0 to 1. And if we simplify that, so that's going to be 1/2 minus 0/2, right? Minus 2 That's going to be 2 over 3 minus 0 over 3. So of course this one is out, that's just 0. So we're left with 1 half minus 3, I'm sorry, minus 2 over 3. Or if we use the least common denominator, that's over 6, right? So this is over 6. So this is going to be 3 minus 4, right? So this is going to be negative 1 all over 6. Okay, so that's for the first 4 problems. Next, we'll go to number 5. Okay, so number 5 is quite simple. So again, we'll just break it down into 2, right? So that's integral 0, 1, 4 dx plus 3 integral 0, 1 x squared dx. If I simplify that, so that's going to be 4x from 0 to 1 plus 3 times x cubed all over 3 from 0 to 1. Right, so we have that, and that's just going to be equal to 4 minus 0 plus 3 times 1/3 minus 0, or just 4, 4, and then we can simplify this one, right? 4 plus 1, then that the rest will be 0, so this cancels out, and we're left with 5. Okay, so that's the answer for the fifth problem. For the sixth, let's go here. So again, this one is equal to x raised to 1 half, right? So this is 0 to 4, x raised to 1 half dx, or again, that's just equal to 2 x raised to 3 over 2 all over 3 of 4, 0. Then this is equal to 2 times 4 raised to 3 over 2 all over 3. Now, if you solve for 4 raised to 3 over 2, you'll find that that's equal to 8. So that becomes 2 times 8 all over 3. So this becomes 16 all over 3. Okay, so we have that there. Next one is a special one. So by rules of integration, you know that ln x, the integral of ln x, so that's x, right? ln x minus x. So in reality, it's an application of integration by substitution, but it's commonly accepted as a typical rule. So we'll just evaluate that from 1 to 3. And you're going to get 3 ln 3 minus 3, okay, minus 1 ln 1 minus 1. But ln 1, that's 0, so this entire thing cancels out. And you're going to be left with 3 ln 3 minus 3 plus 1. So your final answer is 3 ln 3 minus 2. So that's the answer for that integral. Then for the last one, we just have something with respect to u, but it doesn't matter for as long as we keep the same convention. So we're just going to break it down again. So that's, if you notice the coefficient of this first term, that's 1/3 integral. So in this case, it's from 4 to 2, quite a weird integral, of u squared du, plus integral from 4 to 2 of 1 du. Right? And this is, again, equal to 1 over 3 times u cubed all over 3 from 4 to 2, plus that's just going to be equal to u from 4 to 2. Okay, so if you simplify this, that becomes 1/3 times 8 over 3. So that's 2 cubed, right? So that's 8. Minus, if you cube 4, so that's 4 times 4 times 4. You get 16 times 4, that's 64. Okay, all over 3. Okay, plus, for this one, that's just 2 minus 4. Okay, so we're going to be left with 1 over 3 times negative 56 all over 3. Okay, plus negative 2, right? Then if we simplify this further, that's negative 56 all over 9. Okay, then this term here, if we Express it in the least common denominator, so that's over 9. That's minus 18 over 9. And we're going to be left with negative 74 all over 9. So that's it for our examples on definite integration. I hope you were able to see how we applied the basic rules. And I think if you just keep on practicing, you'll get to master it quite quickly. So in the next video, we're going to start our discussions on areas under curves and potential applications of integration to economics, as well as other techniques in integration, such as integration by parts, substitutions, and through the use of partial fractions. So thank you for your attention, and I'll see you in the next video.